about I think this should run now correctly without me my settings killing it. I really hope this is better. Yeah, so right, my CPU usage dropped massively, what's good, and other things. Right. So, yeah, welcome back to the stream. So, what I actually wanted to do, right, this stream, was, so I put a Twitch pick thing down, right? And one of you guys responded with what I should do for next stream, and the thing that came up was reflections. So I think it's time to add some reflections to the scene. Also, I don't know if you guys can notice, there are still skip frames. Why are there skip frames? I think it might be fine. I'm not sure. I mean, my GPU and CPU aren't being used that much. Right, let me wave my hand and see what that does in stream. No, that looks fine to me. Okay, sorry for the impression setup, right? So this is the first time using Streamlabs instead of OBS, but this allows me to do a bunch of cool things that I really wanted to try, so that's what I've been using, right? And I've got a new camera set up, what hopefully should be much better, and what you might be able to see, I got a light as well. However, it seems now my camera has gotten loose, right? So we got a new camera and new lighting, so hopefully that should be much better. And I now look crisp, hopefully. I hope. I really hope for the money. Anyway, sorry. So, what we can see with the Raytracer, right? So what we did last time was the following. So we have now a model running in the background that spins around with textures and stuff like that, right? So now I want to add another model, which should be pretty easy. So let me close all but this, and then open the main, right? No, not this main. Main.cpp. Okay, there we go. And then application. Right, I forgot what's in the application nowadays. And then here, I want to create another model. And, right. So cow1, sorry. So I want to create a model. So auto model2 equals, oh, no, I don't want to run that. I'm being clumsy here. So we make a cow. Then we say model data equals this, yeah? This is model 2. And material is default. Right? And then we say test scene models.pushback model 2. Okay. Then we also want to set model2.transform.set position. Let's put this a bit up, right? So this would be 0, 0, 0, like 5, 0. Alright, and this would need to be a GLM factory. Okay, so now we should see two models. Okay, perfect. That's actually exactly what we want. However, it's still quite big and it's kind of in my way. So let's move it a bit to the right and put it a little bit higher, like 7. And model2.transform.set rotation. And let's put this to like 0, 45 and 0. So this should be slightly rotated on the y-axis. Yeah, I think that's good. However, we don't have a texture, what is kind of concerning. However, oh, right, I think that is because, yeah. Right, so this shouldn't be this should be model 1, model 2, model data dot loaded in material. Right, and we send that, and then we do need to do this. Because the loaded in material for this is actually black. So now we should have a texture as well. Yeah, there we go. That's perfect. Okay. So, in the material now, if I take a look here, do I have... Yeah, I do have a reflective index. Okay, that's perfect. Okay. So, let's go to the Raytracer and add a line here. So, if we apply shading, we don't really need this else here, we can just return. Then, once we do that, we want to not return this, so we want a GLM vec3 shading result, right? And that is equal to apply shading. And then shading result plus equals the reflective result, right? And then return that. Return shading result, okay. So then let's make a function called reflect. So this can be a private function. So GLM vec3 reflects, and this takes in the hid info and I guess the ray. Yeah, we need the ray as well. So let's just take in a const ray. Const ray reference ray. Okay. Then we do this. Okay. Then we call, actually there's a function in GLM reflects, right? And this takes in the normal. So let me double check this, right? GLM reflects, because the information here is always, I think, a bit vague, or at least I shouldn't say vague, but it's always a bit hard to read in the code section. The actual documentation is a bit clearer, or at least when I read it with ReSharper, right? So this would be array.direction. So GLM vec3, this is reflective, reflects there, and this is equal to GLM reflect. So we got the direction, and then we do hit info dot hit triangle dot get normal. However, we need to multiply this normal with the transform, right? So we need to do this, or get this one. And this would be hit info dot hit triangle dot get normal. Right, multiply, GLM normalize. I might have missed a bracket. No. Why is it complaining? Oh, right, because it's going to return a GLM vec4. So we need to cast that basically to a GLM vec3, right? So that's that. That's that part. Then there's this one that's part of the normalize. Then this one to close it, and then this one from the reflect. Okay. So why is this still complaining? Because we do need the closing bracket, right? Oh, it still seems we're missing one. Okay. Perfect. Oh. Okay, perfect. So that should be working. And then we simply say GLM vec3 reflective reflective color is equal to. So basically, what we want to do is call trace again, and with the new ray direction. Okay. So I'm just pulling up my old ray tracer to just double check my logic, so I'm not making a mistake here. Because if that's the case, we should be able, or very easily be able to implement reflections. Should be like tool lines. So ray tracer. I'm just checking my older projects. So give me 1 second. Yes, it's just plus equals reflections. Okay. And that is just reflect, cool, test. Okay. So first thing we check, if hit info, if hit info dot material dot reflective index. So if reflective index is there, so it is greater than 0.f. Then reflective color equals trace, and then we want to construct a new ray. Ray, reflective ray, and then we pass in the origin would be hit info dot world intersects, and the direction would be the reflective direction, right? And this is what we would normalize as well. Although, is it? Yeah, but with a length of x. Okay, so it's already normalized. Okay, so trace reflective ray, and its current depth, right? So we need to pass in the depth here in this function. So this would also need a const int depth, right? And this would be depth plus depth. Sorry, this would be depth plus 1. And this. Hey Beryl, welcome back. My day's doing great. I played some D&D today, and I can finally test my new stream setup. So, how's the new camera looking? I'm curious because I'm really excited about it. Because there's quite some improvement made to my setup. But yeah, thanks man for joining the stream. Okay. And then really simply return this. Return. But yeah, the only thing I could say that could be better is that I'm quite tired. Yeah, okay, so somebody else mentioned the echo. Wait, let me actually check the stream audio. Is the echo that bad? Oh. Okay, that's actually a problem. Okay. Let me wait, okay. Let me retest this. Hello, test. Interesting. Oh, okay, wait. Test. Oh, okay. Oh, that's so much better. Right. Right, can you still hear it now? It should be gone, I think. Yeah, okay, so this was actually something on my end. No, I don't want to put this from on. So, what happened, right? So I got the Avocado Cam link, And apparently it was also picking up the sound from my camera, and it was creating a massive echo. What really wasn't the... I wasn't supposed to do that, so that was something very bad for me. Thank you. Thank you for noticing, because that actually sucks. But yeah, I'm doing good. Sorry. Right. So we have shading results. Reflect. Yeah. Oh yeah. I just listened to the stream and it was actually horrendous. But I have apparently so many like audio things now that like that are showing up that it's kind of horrendous. So I've been using OBS Streamlabs for the first time, and it has a lot of cool things in it. However, like I also have cool things like this, right? So if I do, for example, this, right? This is a test thing. So if people like subscribe or follow or do whatever, right, it will put a thing up. But that they all make audio and they all show up in the soundtracks. So I didn't notice the cam link was making noise as well. What, to be fair, is kind of a horrible oversight of me. But yeah, I'm glad I got it fixed early on, because I wasn't streaming for that long, luckily. But it's a shame, because yeah, I did something stupid. Right, so fingers crossed, I actually now have reflections, if I didn't do anything stupid. Right, so first I'm going to run this, and there should be still the same 2 potatoes. Yeah, no, I do mind though. Okay, so this worked perfect. Both potatoes disappeared. That was exactly what the plan was. Oh, right. Return shading result plus equal plus reflection result. Right. This was actually something stupid for me. So shading result text in the color. Yeah. Okay. Cool. Right. So we still have the 2 potatoes, right? Okay. So now if I do this, application.cpp, then I go into my horrible scene code, cow1.material.reflective index equals 0.5. So now the bottom potato should be reflective, in theory. I call this a perfect win. This is exactly how it's supposed to look, I think. No, I think this is honestly, I think this is perfect. I don't think we have to fix this at all. However, I think I might know why this is happening. So if I go to the Raytracer, then instead of this being the world intersect, I add the normal. So let me put a glm vec3 normal, and this is equal to this value, right? So that's the this massive function, and then we don't need the implicit vector 3 construction here, because that's kind of being taken care of. Right, so this should construct it. I'm still missing something. Right, I'm missing a closing thing. No, I'm missing more. Okay. Right. Yeah, there we go. And then we put in the normal here. And then we miss another bracket. Okay, cool. So then we say plus normal times epsilon. So glm epsilon, and this would be of type float, right? So this should hopefully fix it. If this fixes it, I can explain what's happening, right? No, okay, never mind. It wasn't this issue. Reflective ray, I really had hoped that would fix it. However, we could still I can still test something else. So I kind of want a bigger 1e minus 4f. Kind of want to see it up. Right, so I'm using Visual Studio. Okay, this is better. Oh, I see what's happening, I think. So yeah, I'm using Visual Studio to code. Yeah, I'm sorry. I didn't mean to purge the Irish audience. I'm working hard on regaining the potatoes. I think it's simply too reflective. Right. Oh, yeah. You know what's happening? So it's perfect reflective. So you can actually kind of see the shape of the potato here. However, it's perfectly reflecting the background. So what it should be is it needs to take care of the reflective index. So this should be multiplied with hidinfo.material.reflective index. Right. So it's multiplied by the reflective index because it doesn't take the entire background color. Right, so this is a bit better. Yeah, so we can see that this part is fully this color, but this is kind of green-ish because it's reflecting the background completely. So, in theory, if I go here and say with this here, right? I don't set the material here. This should get rid of the... I think there should be a white model now. Yeah, so I could do the following, so I can make it red. So now I think I should see a red reflection. Okay, that's not quite what I was hoping, but that's perfectly fine. Okay. This looks, although it does kind of look reddish to me. Right, I could actually test this by making this material completely blue. So if there is now a red hue on the model, it should work. Interesting. I think it's easier to test if I don't use the materials at all. For the textures for now. Interesting. Because we can definitely see kind of a green hue here, I think. What's interesting. So if I put this reflective index to 0.f again, right? What color is it? Okay, it's green. Oh, it's... Oh, oops. I am... wait, sorry, it's RGB. Yeah, no wonder I was not seeing a lot of issues. If it's close to the background color, it's not going to make a huge difference. Right, so now we have a blue one and a red one. Okay, that should give us a bit more contrast. If we then upgrade the light color, sorry, the reflective index, we now should see the... Yeah. So now this is kind of a greenish hue, and this is kind of a purplish hue, right? So that would mean it's working. And if I put this up to 1, that would mean it's fully taking in it's like a perfect mirror. So it means that we should end up with... We should end up with a completely red surface, but it clearly isn't. So I'm definitely doing something wrong. Because I think it's definitely doing something with the color, however it's not quite correct. But I think I can fix this. This shouldn't be too bad. So let me open my other project. Can I just change this easily? No, of course I can't. Okay. I would have been really nice if I could, but apparently we can't. However, we can just do display capture, add source, display capture. No, no, there we go. And then put this to the bottom. Right. So this is my old project, I think. Now that should be fine, right? Because the basic idea, right, is that I think you can see my mouse, right, on stream? I think. Let me... No, of course you can't, because I am an idiot. Right. So let me open Paint, right? So the idea is, right, that we... Like, these are the two potatoes, right? And we shoot a line. So this would be the camera line, and it hits, right? Then it does the shading, blah, 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 but then it reflects as well. And then it shoots a ray here, and then this potato is red. Like this potato is red, and this potato is blue. So this gets a red color from here, and it should add the red color onto the material. So I think if we actually make this material white, it might be better to see, because it might actually be doing it correctly, because it's shaded in purple, but then it adds the green on top of it. Because I think that actually might be correct. I think it might actually be correct what it's doing, thinking about it. So what if... current tracer, right. So what if I make the material completely white? The reflective index, because then it should actually be a perfect mirror. Right there. Oh, this looks better, right? So now we're getting a purple, a red color. However, I think it's, yeah, okay. No, we're actually getting a red color. And I think this might be correct. Yeah, I think this is good. Because what this basically does, right? So to walk through the code. Actually, let me explain this in Paint again. So we shoot a ray out, and we first arrive. So this is the trace function, right? This line. Then it arrives at this object, it calculates shading, whatnot. Then it is done with the shading. Then it checks for reflections, and then it says, "Oh, no, I'm reflective, so I need to trace again." Then it traces again. It does shading. It does reflection. But however, this doesn't reflect, so it ends here. It just gets the shading information and then returns that. And it says, "Oh yeah, but I'm reflecting red as well." But yeah. However, what we're doing with shading currently is actually not perfect. If most of the red light is absorbed on the blue surface, there's not much to be reflected. Yeah. So that's kind of what the reflective index is, right? So if the reflective index is 1, that would mean it's a perfect mirror. So that means that all the light hitting it is reflected. But if it's only, for example, 0.5, that means half of the light gets absorbed. So that means the reflective color will be much less intense. So if this is 0.2, right, for example, we can see that the impact is much lessened. So we can now see that it's more whitish, but it has a reddish hue to it. However, we're not taking into account actual shading. So we're only doing currently a technique called Blink-Fong shading. So it takes into account basically the following principle, right? I'm going to go back to Paint. So if you have a light here, this is a big light. if you have a array here, right, like directly on the surface, it's going to be very bright. However, if you have a light here, on this point, it's very stretched out, the surface of what the light hits, so it's going to be much darker. What gives a pretty good shading. However, this pixel might still be lit, because if we go here, we can check the normal and be like, oh yeah, but that's actually lit up, right? For example. It might not do that because other things, but it might give values that are here could say, oh yeah, but I'm actually lit up. However, in reality, they can't actually reach the light, so they should be black. However, the shading doesn't do that. But we can actually improve this. But this is now currently just a simple estimation. I hope that makes sense. So what we need to do is we basically need to intersect again to all the lights. However, we have this in the Bvh, right? Bvh, right. We have this intersect. Yeah, we have this intersect function. If I can. No, this is the model. Let me find it. I'm completely blind. Right, Bvh. Wrong file. So we have the intersect function. So what does this do? It traverses the Bvh and it checks all the models with the fancy stuff and gets the closest one. However, with lighting, we can kind of optimize this. So with lighting, all we care about is that we hit a object. So if we hit a single object, we can return. We don't care how far it is, as long as it's closer than the light, we know we hit it. So what we can do is make another function here. So this takes in a const, no sorry, this is just a bool, light traverse, and this takes in a std vector. So this takes in a glm vec3 light pulse and a const RT model. Yeah, it's an interesting experience in programming. But yeah, even then, I'm like not an expert in like true realistic rendering, right? So some friends of mine on school are working on like actual realistic rendering, and it's really awesome what they can do. But there's quite a lot of math in it. So for me, it helps that I've done most of this math before, so I can cheat on my code basically, because I can just steal a lot of things from last year that I did, and basically just change it to fit my current ray tracer and improve upon it. Right. So we need this one, and this will just be a bool traverse Bvh, and this will be called early out. This takes in the model, the current node, the array. No, we don't care about the box distance. We don't care about this. We do, however, care about the light position. Right, and this can, yeah, exactly. I mean, even though it's like a lot of the same code, right? It's still very different in a lot of ways. So this would be traverse Bvh, early out, model, roots, or m.nodes, m.node 0, array, and light pulse. And this, I just made a mistake as well, so these should be both const functions. Yeah, that one is const, however this one isn't const, but is important. So it takes in a model, yeah, a node, yeah, a ray, and a light position. Why is that not okay? Subdivide, no, no. So it's the model, current node, ray, light pulse, yeah. But this should be a const glm vec3 reference. Right. So why are you still complaining? Because this takes in a model, yeah, we're passing in model. What is it, const model data? Oh, right, so this should be model data. Okay, sure. Model data dot get. My bad. That was actually stupid. So first we are there, right? Then we take this code. We take all of this, copy it, and then we check this, and then we check if it's closer than glm distance, ray.origin, and oh no, you know what? I don't actually need to pass in the light pulse here. I want the light distance, and this would be if this is less than light distance. Right. And then I don't need this one. Okay. And then this should be called light distance. Because we don't need to recalculate this variable 3000 times, right? We can just use it once, and that's perfectly acceptable. So light traverse, so we would have a glm vec3 distance to light, and this is equal to glm distance ray.origin and light pulse. However, no, this is fine. glm distance, why does that not work? Oh, it should be lengths, I think. No, it should be distance. So ray.origin, yeah, that should be okay. And light pulse. So there is the, yeah. It's 2 points. What's the problem? Because this is a vec3, and this is a vec3. Right, so this is a different type actually. Okay. Yeah, thanks, Jinx. Yeah, the webcam is doing really nice, I think. I think it looks awesome. Or so I should actually say proper camera. However, I actually have no clue how it's doing with the battery life. Maybe I can actually check it. No, I can't. Okay, that's cool. So the webcam, oh, sorry, the camera might die between now and 20 minutes or an hour. I really don't know, because it has actually managed to get fully charged. However, I don't know how long the batteries are going to last. So on Wednesday, I'm going to get the dummy charger in, so it actually can always stay charged. However, when I bought the cam link and camera, I forgot I needed the dummy battery as well. Yeah, it's really cool. So I'm actually wondering if, like, this is better, right? If I turn the lights a bit lower, because it, oh, this might be better as well. So now just a, I think this is a bit overlit. I think this is good. Just it's like very, very slightly lit now. Right. Cool. I can change the temperature as well on this. So it becomes more, I don't really actually see a difference here. Okay, so this is actually really cool, right? So I got a Stream Deck. So what I can do, right? I'm trying to find the buttons here. So I can change it via the Stream Deck. I think so. Yeah, apparently, right. So this is so my ex-girlfriend actually bought me this sweater when she was on excursion, and the sweater itself is amazing. I don't know about the print though, but the sweater itself is really nice. But yeah. Oh shit, okay, well, I suppose I have to get rid of it. I'm luckily wearing something underneath it, but no, I like the hoodie. I am so confused why this is not working. Or do I simply not have the geometric functions included? Right, would this be happy now? Yeah, thanks, Jinx. Have a good night, man. But yeah, the lights are on Wi-Fi actually, so I can control them completely. But I can also change my I can also change things on the stream, right? So with a click of the button, I can, for example, do this, right? I can switch scenes, and I have different scenes as well. I can also actually, from the Stream Deck itself, monitor like CPU usage, GPU usage, temperatures. It's really, really awesome. It makes me really excited. Also with the button, I can start and stop the live stream. I'm really hyped for this. And it has like a proper webcam now, the key light. I think it's really, really cool. Did I go overkill with this? I might have gone overkill a little bit. Why is it doing this? This should be okay. Yeah, okay, so this is actually something about me, right? So this isn't really a great thing. So what I tend to do is I go completely overkill on things. What really isn't the best thing. But yeah, if I usually do something, I want to do it well, right? And I really shouldn't be doing this because it's actually quite a lot of money, but it's fine. I really like streaming, so it makes it up in emotional value or something like that. I don't really know. Minus. Right, okay, so this works. Okay, sure. Then we'll just calculate the distance in the old-fashioned way. And then this is distance to light. It really bothered me that this doesn't work. The GLM distance thing. Yeah, it really should be fine. Oh, okay, so I forgot to take the length of this. So I don't need the square root here, I just need the GLM length. Wait. No viable constructor. Huh? Okay, wait. This is weird. Right, ray direction, right? Sorry, this should be ray origin. Right. Nah, I think it definitely knows, man. I mean, why else would Windows be doing it? Like, it definitely knows that it's not working. I have used GLM distance before. Yeah, look. Oh, I think it's between 2 points. Oops, did I do something stupid? Yeah, no, this should be okay. So yeah, this is the distance between bound 1 and bound 0. Huh? No, but this is the axis. Okay, sure, we'll just do it. Oh, no, cancel. This is really taking longer than it should have. Light pulse minus, and then this is GLM length. Right, and let's construct just a GLM vec3 here. No, huh? Right, because the weird thing is, right, so this takes a GLM vec3, this takes a GLM vec3, and it constructs a GLM vec3 with a GLM vec3. Okay, you know what I'm going to do? I'm actually going to restart my Visual Studio, because this is bothering me. So basically I'm doing the exact same thing as before, but for some reason the function is just saying nope. Oh, that's the wrong projects. So GLM distance should give me the distance between 2 points, but for some reason the function is just not giving, not working at all. What is kind of bothering me, because this is the usage from it. Right, let me just build it and see what it does. Yeah, it filled, okay. Can I see why it fills? Error, no installation. No, sorry, this isn't where it crashes. Where does it actually error? Oh. Wait, why does it fail to build? Okay. I am really confusing myself today. Alright. Let me just comment out this and comment out all the traverse code. Right. So comments. Now we just have the this. So if I comment out this, there should be no compile errors. This should compile fine. Okay, yeah, this compiles fine because it's literally what it should be. Right, and this is obviously not going to compile because of this.
what the? Because this is what it. Because this should work. I really don't see why this is not working. Right, so this compiles, okay. So light pulse, okay. Okay, what? You find that okay. So I do distance, and this. I'm actually stupid. Right. So the distance is a number in like units, right? And I was drawing it as a vector, so obviously it's not gonna work. I did actually something really stupid. That's what you can see after playing a night of D&D, that your brain sometimes stops working. And this should be a const float instead. Right. Okay, that works. And then we return. Okay. So then we can put all of this back and finally fix it. Yeah, so I was treating distance as a direction, basically. What doesn't make sense, right? It's just a unit, right? Because distance is just like a value between, like, say 0 and 10. It's 10 units away. However, I was saying I was basically treating it as a 3D position or direction, what really didn't make sense. So it's like saying the following, right? So you're saying I have an integer, so type int a, and it's equal to like some string, right? Like you're saying two completely different things to each other. Well, obviously doesn't compile. However, my stupid brain was too stupid to realize what was happening, because I'm tired as hell. Okay. So if we do this, return false. Okay. So then if we hit something, we return true. Okay, so this is pretty similar, right? This code. So if we don't hit the node, we return false instead of like returning null pointer, because we don't care about the shape. If we hit anything that's closer to the light, we return true. And then in here we say instead traverse Bvh early out. And we say, so we need the model node ray, and this instead should take the light distance only. But yeah, I hope that explanation made sense, man. Right, so so this is actually a bool. And this is equal to false. False. Okay. Yeah, sure, this is actually being used, but we don't care about it. So if this equals true, if this equal false, and this is equal to false, then right, we can't do this. And if that both is true, return true, and this should be return true. Nah, let's do so they both hit, it's return true. Okay. No, wait, we don't have, so if, so right, so if, we can just do the following. If left shape equals false, or, sorry, so if this is equal to true, or right shape is equal to true, we return true. And else we return false. Sorry, don't need, you can just return false. How long did the store take? Assuming your walking speed is 1 meter per second, the stores. Yeah, exactly. That's exactly the kind of thing that I'm sometimes dealing with. And it's like, how do I solve this? No, you don't. Alright. Yeah, I think this is working. So, you guys might be wondering why we need this specific method, right? So with before we were checking all the shapes that potentially hit, basically, and with this we skip everything else if we hit something. So it's a bit faster. So now with the lighting, because this was all for lighting, but we're already going over the point lights, so we're multiplying. We're actually going to do the following. So int mod or light visible is equal to static as int. Yeah, definitely optimization is good, but they do also say optimization is the cause of all evils or something, or the root of all evils. However, it kind of depends. You have optimization and you have optimization. If you're making something faster that doesn't need it, it's stupid. However, if you're doing something because it actually has a good reason, it's not necessarily bad. Right. So we do kind of need the transformed ray for this as well, because we're gonna need to pass it into the Bvh again. Okay, sure. We can pass that into the shading as well, so then we would have another ray. Const ray reference. Transformed ray. Right, no, we need to do this a bit more in depth actually, sorry. So we need to copy this and put this in here. So we don't care about this. We do care about the model ref. We care about this, and this is Bvh Light Traverse, and this is right, so we pass in the light position, transformed ray, and this is I need the light, so that's light. Oh, and then light dot position. Right, and instead of the ray origin here, let's just pass in the ray. And then ray, and this is just called ray. Oh. Oh, and then we copy ray, and then that is in here. This is ray.ray origin. Why can I not do that? I'm pressing in. ray. Oh, ray.origin, right. Okay. So we do need to do this. Right, so we have light visible. What needs to be in here? So for each model, we say this is bool hit. So if hit, break, and we set so int light visible is equal to 0, sorry, is equal to 1, and otherwise we set this equal to 0. Yeah, okay. So I think this works. Okay. And then we do another if, so if light visible and else right. And if that's not the case, we do this. So if the light is visible, we do all the cool shading stuff. Because if the light isn't visible, right, no point in applying shading, because it's black. Is it badly optimized or actually good optimized? Because unoptimized. Okay, yeah. Minecraft, yeah, because from my experience as well, Minecraft has been not always great. Wait, I actually can make this a bool instead with this approach. So if light is visible, yeah, and then we don't need this weird cost either. Ah, yeah, no worry. Are you on phone or Barrel? No, okay. Apply shading. Oh, right, this should be just ray. There we go. Now we have shading, I think. That does look to work. So are there pixels here that so else I kind of want to do a printf filled and then /n. I just want to check in my console if this ever gets printed. No, we always seem to hit the light. Okay, that's perfect. Oh, wait a second. So if through, oh wait, sorry. So this returns something, sorry, this returns something wrong. So this needs to be, so if hit is false. Right, so if it hits something, so if this is hit, right, we set it to false, sorry, so I was doing it the wrong way. So yeah, now we're also getting filled pixels. However, it doesn't seem that we're getting it. However, we can, I think our lights are pretty strongly placed. So I think if we get application and if it's from my account and just from the laptop. Wait, really? It doesn't get 5G? That's weird. That's actually really weird. Okay, we only have one light in the scene. Okay. However, what we can do is put this on 0 and just high up. But yeah, luckily you should be able to get your computer soonish. Yeah, there we go. Now we can actually see shading, right? So you can actually now see that if in case it's something isn't visible, it will actually be black underneath. However, I am also curious why. Oh, okay. So this is interesting. It doesn't take into account shading here correctly. That's a small problem. So, right. Oh, I think this is actually a very easy fix to do, though. So it should be shading, I think, times reflections. No, should it be? I think so. Yeah. So this is, sorry, Raytracer, and this should be times reflections result. Ooh, okay, that sucks. Right, this is definitely doing something. So if I move the light back to where it was before, this should give me actual decent lighting. Okay, it's incredibly dark. What makes sense, because if it's not, if it isn't reflecting, it should return 111 then. Right. So instead, reflecting, so return 111. Okay. There we go. So now we can see blackness here, and right, this is pretty dark, right? Because the light is kind of like here, right? So this is mainly being blocked by the point light. So I think if we go to the lighting application, so move the light to the right, so let's say 6. I think now the bottom potato should be a bit better lit. Yeah, I think so. I could put the intensity up. Oh, oops, that's the camera, not the lights that I moved. Yeah, I think I moved the lights the wrong way as well. So I think this should be -6. Let's see what that does. Because the specular kind of looked like it was on the left, on the top potato. Yeah, no, it's definitely more lit to the bottom. So if I move it lower and put the intensity up to like 100. Because the bottom one does seem very... right, yeah, that's definitely brighter. Yeah, now we can... The bottom one is clearly brighter as well. However, it still seems very dark to me. What could be because of the oh, what if I put the reflective index up? Right, okay, so there is something going wrong here. So basically, right, if this is 1, it will take... It shouldn't be pure, it should be not quite this. Well, it doesn't sound very confident, but if we straight up add it, it ignores the lighting. However, if we do it like this, so right, so if we add it, it ignores shading. However, if we multiply it and the reflective index isn't 1, it will become darker because it's multiplying it by like 0.2, for example, right? We'll make it darker. Okay. So let me double check my ray tracer. So calculate shading. Oh. However, how does the... Huh. This is an interesting problem. Right, now it should definitely be adding them. Raytracer, so they should be adding. Hit options, so this should be plus. So let me think about this. So we get the reflection result, right? However, if it's shaded, how does that? Right, let me do some quick research online on how they do it, right? So they... And how do you add this? Let me open the source code they have here. Okay. So Fresnel, blah, 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 blah. Okay. So hit color. Okay. Oh, wait a second. Okay, so what we can do instead is we change this a bit. So we reflect first. Okay, no, I think I got a solution for this. So we reflect first, and then we don't do this. We return shading result. However, shading result now takes in a color GLM vec3 reference, and this is color. And this should be here as well. Color. And this should be some value that we're going to calculate here, right? So GLM vec3 color is equal to GLM, hit info dot material dot get texture times, this can be, hit info dot material dot get texture hidden, right? So we have this here. Right, texture color, that would be this. So text color. Then I want the diffuse color. What is set here, I think. No, where do we put it? Oh. And this is a const GLM vec3 reference, right? And this is color. So I did set the color to be equal somewhere to the base color. Oh, there we go. And then text color we can set as equal to this. Right. Okay. And this is 1.f, 1.f, 1.f. Sure. No, sorry, this is equal to color. Okay. And then this text color times equals this. And then we pass in text color, right? So then we apply shading last. And then they should be moved up as well. Okay. So we reflect first, then in this, we multiply this as well with the text color times equals reflection result. Or sorry, I can do this in one line, right? So say text color is equal to times equal this times reflection result. Okay. And then we apply shading. So this should be fine. No. Oh, right. Sorry, this shouldn't be const. This should be. No, wait. This can actually be const. Right. And then we shade. Yeah, then we have the shading result. But this is now taken into account the reflection. And then it shades that. Okay. There we go. I think that's okay. That looks bright. So if we now turn down the reflective index to, say, 0.2, do we still keep the brightness? Yeah, we still do. However, it's now darker in the sense that it's much wider. So if we put this to, let's say, almost no reflection, it should still run. It should still be light. Yeah, it's just white. Okay. So put this to 0.2 and then put the light straight up. So 0, 0. Yeah, thank you. I've been working hard on it. There we go. Okay, that light should be higher up. So now the light is straight above the potatoes. Yeah. There we go. Now we can see proper shading. And now we can see that this is kinda very red, very light red hue. And this is very bright. And we can see that for some reason this is getting grayer. What would make sense actually, because we're getting reflected less and less, and this would be getting more faded to red, sorry, to black as we go along. So I think this is fine. And this is reflecting, and I'm assuming this is correct. And as well, keep in mind that this surface is going to be incredibly distorted. Most likely. Because we have like all tiny squares that all point to certain directions. So it's probably quite yeah, quite distorted. It won't give you a perfect reflection like a sphere. However, I do think it's correct. Right, however, it's kind of hard to judge. So I think this potato, where is the second potato? Right, so if I put this, the Z is still at the same one, okay. So where is the other potato located at? Because I think it's at 0, I think it's at 0, 0 as well. Yeah, it is. Okay. So why is the bottom potato being lit? That's actually a very good point. Why is the bottom one being lit? So if I don't rotate this, do I get shading? Oh, right, it's still being... okay, so now the bottom potato should be fully dark, pretty much. No. Okay, that's actually interesting. So it should be very dark, however, it clearly isn't, as we can see, because the light is right above the first potato shining down. But for some reason, it isn't. Okay. And I want to check something else because I just noticed that we still have the printf in there. Right, we don't want the printf. So it's actually insane by how much our FPS dropped for having two models. Or it might actually be the... I'm wondering if it's the reflections or the lighting. I think it's mainly the reflections. So if we do... so if I do reflect, if I just return this, right? So this should speed it up dramatically, right? Not really. Okay. Right, so what I mean with it, right? Let me reopen the potato. So the light in the scene is right here, like on top of the potato, on top of the top potato, and the light is going down. So that means that here it shouldn't reach the light at all. Right. However, it does. Ooh. Because it should block the light, because it's going straight up, so it should hit this potato. So let me see in debug if I can check the reflection. So reflect in here, okay. So what is my normal? Oh, so my normal would be this, so that would be, no, that's fine. So the reflection, no, sorry, I'm looking in the wrong thing. It's the, it's in here that we should be looking. So the, right, TRD. Oh, wait, yeah, nope, I see the issue. Yeah, okay. So this isn't the original ray, this is from, right, this is ray origin. No, sorry, this is light position, light dot position minus oh no, sorry, this should be hit info dot world intersects, and this should be GLM distance. No, it shouldn't be distance, right? It should be GLM. No, I think that could be distance, and it's from light dot position to hit info dot local intersect. No, sorry, world intersect. Yeah, so I just realized I completely scuffed up this. So I just copied the top code without thinking about it at all. So that still doesn't shade. Interesting. So this should still block it, however it doesn't, right? But now we did change it to take in the light position and the world intersect. So now this should be the actual direction, and this now starts at the intersection. Light position, okay. transformed ray. Okay. So debug. So I can just put a glm vec3 here. Yeah, glm vec3 to light, and this can be, yeah, so we have this variable actually, right? Light direction that we can put here, up outside of it. No, let's actually not do that. So this would be to light, and that would be this function. And then this takes in to light. Yeah, thanks, man. I think I'm gonna get some sleep soon as well, because it is getting quite late. I'm just gonna see if I can fix this, and then I'm probably gonna take some sleep as well. But yeah, thank you for joining in, man. It was good having you around. Right, model to light is to the isn't this should be normalized. So light position, yeah, okay. So to light isn't normalized. Okay. Interesting. Oh, wait, this is the distance. No, what am I doing? I'm actually stupid. Right, so this is light position minus, right. So let's see this. I can really notice that when I'm tired, right, my brain stops working and we get weird, I get horrible streams that, or at least the streams themselves are not horrible, I think, or I hope, but the coding quality becomes horrible because my brain definitely lacks brain capacity to completely think straight. Okay, so the to light is now a bit to the left, up, and a bit into the screen. That seems fine. Okay. So light traverse, sure. So if hits, so don't hit anything, okay. Then the light is visible. And we have only two models, right? Okay. So it's false. Okay, so light is visible. And then we do the thing. Okay. So if it's not, we return out. Oh, right. And out is black. Okay. So if we do this, out can be black. Okay. That seems correct. So is there ever a, there must be an else. Yeah, no, there must be, because otherwise there are no black pixels. Okay. Because otherwise it would always do this. Okay. So then how come we still have, this is still lit up? Because we can clearly see that this shading is looking correct. It's lit on top, it's dark here because there's no light. However, this position should be hit, but then it goes up and should hit the the thing, right? So let me double check my model here, right? So it takes in the model ref. What is the active scene model? Y, okay, sure. Then we get the light direction, yeah, and then we get the inverse light position, yeah, and this is the world intersect, yeah. So we take the intersection point, okay, and then we create an array with TRO, TRD, and then we do the light traverse, okay. And what is this? Okay, so distance to light is 20 units. Is that possible? Yes, because it's the transformed. Yeah, no, that could be possible if it's diagonal. Sure. So then, in case this happens, so if we call this, right? So if traverse Bvh with early out. Okay. So say we go here, float temp. Okay. Do I ever distance to triangle? Okay, so this is true. So we step out, or we don't step out. We return. Oh. Right. So this is true. This is false. Sorry. So if left hit shape dot hit, right? So this is false. This is false. So if this is ever true, we hit something. Okay. Oh, right. This shouldn't be return right shape. It should be return true, because we hit one of them. Right. So that could make sense why it's not working. There we go. That looks correct. More correct, at least. Okay, no, that actually looks horrible. I know though why the spots are appearing, because that has to do, I think, with the position, but we can easily fix that by doing the following. So we go to the Raytracer, and then instead of simply saying this is the world intersects this position, we say this is plus the hit info dot hit triangle. I need the normal here as well. I think I need it here anyway. Yeah. So let's move the normal out. Yeah. And then it's plus the normal times 1e minus 4. Right, so we slightly move it out with the normal. So I think it's self-intersecting what would cause issues, right? So this, now we have a straight color. So this is looking much better. Now the only thing I need to figure out is why it's red in this case. What I think is this is just a simple mistake. So what is return out? So this is, okay, that's interesting. So current light color. Right, okay. So it's set by default to the color, okay. So else out plus equals 0 to f, okay. No, so this shouldn't be no, this shouldn't be set here. So this current light color is 0, but this is yeah, so it's color multiplied with the following. I think that should fix it. There we go. Now it's black. Now this is fully black. What I think is correct, because the light would be just above here. So if I now... Nuts, thank you for following. Hope you're enjoying the stream, man. Okay, that alert actually scared the hell out of me. let's make the alert box a bit quieter. That was very, very loud. Right, so yeah, so I was moving the light, right? So this instead is point light, right? Yeah, no problem, man. This this is the first time using OBS. Sorry, not OBS. Streamlabs OBS. So this is the first stream as well that I put the alerts in, and you're the first person since then that followed. So the alerts scared the hell out of me because it's so loud. Because it's supposed to be like a just a background audio thing, right? However, it seems to be incredibly loud. Sorry about that. So if I move this light a bit to the left, now we should see the bottom potato being lit as well. Yeah. So now we can see that it's slightly being lit as well. So if I move this lower to say 5 units, we should see, there we go, that this is actually being lit correctly. And now we can see that the reflections are actually looking correct as well, I think. Because this is being lit, so it hits it. I think this is correct. Or at least more correct looking than it was before. So let's put this to 5. Okay. Let's try this. So I'm kind of just one day a scene that looks well. No, it looks worse. However, what I can do is I can move the original potato. So I can put this to like 5 and this back to 15. And then, right, uncomment this and put this to like 3. So I think that way the potato is a bit to the left and rotated. Yeah, there we go. No, I'm still on some cables. Okay. And then I think instead of the light being here, it should be on the minus. So that way we should have a bit of lighting from the right and on top. Yeah, there we go. I think this looks... No, this actually looks garbage. So minus 10, and this can be at 45, and then we put the... Oh, sorry, let's put this at like 30, and then put the intensity up to like 400. Let's see what this does. I really need some way to better edit my lights. You know, I can just add another light if the scene is too dark. I practiced for this. I've added support for multiple lights. So I can do 0, like 5 units. So now we should have lights in between as well. Yeah, there we go. I think that's potentially correct. It looks horrendous, but there is a light. There should be a light somewhere around there. I think we can put it a bit higher. Yeah, sure. I think this is fine. We can at least see that it's clearly reflecting something in here, right? I think that's clear. Okay. So there's actually something else I wanted to add to the UI. So what we can see here is when we have ImGUI, right? Installed. So we can enable something called the normal view, and we can see the normals of the potato. What's pretty cool. So what I was thinking as well, why not see other options? So we can say, hey, I want the reflective index as shown, or I want to see the Z, like the intersection depth visualized. I think that would be some cool options to see. Oops. So I think we can do that relatively simple. What we can do, yeah, we go back to we go to ImGUI layers, and then we open the stats layer. And I think if we, no, sorry, not the stats layer, the options layer. So the ImGUI thing works with layers. And yeah, it works with layers, so every layer basically gets rendered at the end. So I think we can do there are probably, I think there are radio buttons in AmGUI. Radio buttons, right? So how does that work? I'm just quickly looking up how to do radio buttons, because I'm guessing I can do radio button. And then another radio button. Enable depth view. Okay. And then another one. None. Sorry. AmGUI radio button. None. None. Okay. So does this, by any chance, work? Because I don't think I've used radio buttons before in AmGUI. No. Okay. Do I stack them like this? No. Oh, no. Okay, that kind of works, but that's worse. I'm pretty sure the demo window probably has some radio buttons I can take a look at actually. So there is the AmGUI demo window. Do I not have it in here? Should have it. So sources, graphics, AmGUI, demo. Okay. So there should be a radio button, right? Yeah, there we go. So it has to say, oh, it has a static, right. Okay. This makes sense, sure. So the okay, no, I think this makes sense. So then we go back to the option layer, and then we say, so if an int radio button, and this is equal to 0. And then we say radio button. And does this take it by... No, wait. Because what? Oh, it still takes the same... It still takes in the same boolean. Okay. But it takes in as reference, and this takes it in as... Sure, okay. So radio button at, and this would be 0. At radio button dot 1 and at radio button dot 2. Okay, so does this give me the proper radio buttons? There we go. Okay, so this is obviously this obviously has problems because this doesn't do the settings we had before. However, we can quickly change that. So we want a struct, so now an enum, and this would be options. Sorry, so e options, and this would be non-normals, and let's go with depth first, right? And this is equal to 0. And then we would have a, that would cast this to e options dot none, e options dot normals, and e options dot depth, right? And I would say normal delegate, right? So it's say, yeah, okay. So to show normals, we would say we would say yeah. So enable normal view, and this would be none, and this would be empty. It doesn't do anything. If it's enable normal view, it will say bool, yeah. So this would be temp, and this would be true. And then we move temp into delegate, and the delegates gets fired. Okay. And then this is enable depth. And this is the radio button thing as well. Okay. Sure, and this does something as well. Okay. So this we want in the Raytracer. We want a right. So this is we need another delegate that is sig delegate of type void, and it would be dot reset delegate, and this would simply reset it, right? Yeah. So in the application, we have the delegate here, right? And this would be, in the Raytracer, we would have a void reset. So this would be a void reset options. And this simply says m.options equals options. Okay. And then in here, we have another thing called bool show depth. Okay. So in this, we say show sort of reset options, and this is the m.reset delegates. Right. So now it fires the reset delegates when the radio button are ever seen. It resets the options. Never mind. Oh, right. It takes this as a reference, I think. Okay, cool. Bvh, no, sorry, options layer. Right, so this is m.reset delegates. Okay. Doesn't look like that. I think I can just do this and keep it empty. I think that would be fine as well. Okay, yeah, that's fine. Automatic template deduction, great. So if we run this now, it should not have the option, right? Enable normal view, it turns this on. Do the same for this, because it doesn't do anything. And then non-resets it again, okay. So we can have a signal delegates, and this would be of type bool, and this would be m.depth depth delegates. Right, and now we need something in the Raytracer. Raytracer.h, and this would be void set show depth, and this would take in a bool set value. And then m.options.show normal equals set value. Okay. I think we can do this better though in the future. Yeah, we can use some flags for this, but for now this is fine. You know, we can definitely use a flag for this. Yeah, we really should use a flag for this. Because what's going to end up with this, right, is that we're going to need 20,000 setter functions. However, we really don't want that. We can actually do this with one function. So we don't need these functions at all, and we can call this set options. All right, and this takes in a uint 32t. Oh, sorry, this is a int 32t. That's fine. And this is options, right? And then under options, this is instead a int32t options. Now we don't need this, and we do need something here, right? So we have options, new item. I'm just setting a file real quick. Include core. Okay. So this would be rendering options. So we would have a const expert int no effect is equal to 0. Const expert. Oh wait, oh no, this is a slight mistake. So this should be rename, and this is not a CPP file, this is a .h, should be a .h file. Okay. So const expert int normals, and this is equal to 1, like this, right? And then we have another const expert, and it is depth, and it's equal to 2. Okay. Why is this? This is no header file. That's yeah. Okay. Is it complaining about the? Oh yeah, I think it's because this is was built a CPP file. It needs a precompiled header. Yeah, not using precompiled header. Okay. Sure. So that works. Then we do need to change the delegates in the options layer. So this is one delegate that. So this is set delegates. m.set options delegate. Right, and this is a int32t. Right. Then we don't need these. No, we do need these options. We need them for the radio buttons. Okay. Then in application, we don't need to set up all of these. We simply need to set up option. No, sorry. Let's keep this option layer dot m dot option, and then connect set. Didn't I have the change? No, wait. I had that function for this, right? That I just created. Oh no, right. Oh, we changed it. We changed it in here, right? So there's this a void set options, and this takes in a int32t options, and yeah, okay. mdot options equals options. Okay. So application, and then we have set options. And then bam, okay. Then we don't need this other delegate either. Okay. So then we can go back to the options layer. Then m.options layer. So int option is equal, and then we need to include core rendering options. Right. So this would be none. However, this needs to, I kind of want this to be in a namespace. So namespace RT, and then namespace rendering option. Right, and then we put these in here. Okay. And then we say rendering options dot no effect, and you say options. sorry, std move options. And then we simply do this at the very end, right? And then we say options options equals rendering options normal, normal, and this would be options, you know, this doesn't have to do anything, but we can simply do options equals rendering no effects, just to make it a bit clearer that we're actually doing this. And then option equals rendering option dot depth. Okay, and then we fire that delegate. Okay, then in the ray tracer, this is obviously going to complain. So if then we do need to include include core / rendering options. Okay, so if if the options is equal to so if options and dot so rendering options normal. Okay, so this should now compile, I hope. So normal. Okay, right. So we are refiring this too many times. Okay, so we want to fire this but basically only once. Okay, so when we actually click a radio button, we want to fire the event. Okay, sure. Okay, this works perfect. And why doesn't this? So if this fires, it should get rid of the normals. Ah, that's a shame. Okay, so it seems my webcam died. That's actually quite impressive. Right, let's switch it back to my regular webcam and put it on my face. Okay. This isn't as fancy, but it works. No. This is correct. Sorry, I'm a bit messing around with my settings. Right, so this is correct, and I need this. Okay. It's a bit stretched, but okay. Sure, this is good enough for now. This stream wouldn't go on for much longer anyway. So, okay. So we have the depth. So why doesn't, when this fires, why does the normal still go off, right? So we click enable depth view. Okay, so options. This is for, so it's 0 to 4. Okay, sure. Then this get fired. Yeah, ray tracer. Oh, right. So this should be a and, sorry. Not a and. So there should be, yeah, a bitwise and. Yeah, there we go. I think this should work. Yeah, there we go. So then we can quickly add the following option here. What would be else if? So if the options, and rendering options dot depth we want to basically get return yeah, sure, we can just do this on a black-white scale. So no, let's do this on the I like this on the green actually. So we do this divided by glm distance, and then we do hid info dot world intersects and hid info dot distance. Oh, sorry. Oh, there's actually just a distance thing. Okay, that's actually great. So divided by hid info dot distance, and then obviously this needs to be done in once. And this is then a glm effect 3. Okay. So this should give me basically a depth view. Okay, sure. So if I move the potato very far away, you know, let's actually change this to be the blue channel, because that's a contrast quite a bit more against the background. Okay, so if I move the other potato, so application, then I'm gonna say the potato. No. Right, so this should be, let's put this set to like 100, right? So now the distance is quite far. No, oh wait, sorry, I think I put it in the wrong direction. Yeah, that's positive, so that's towards the camera. Right, so now the potato is very small. So this is blue and this is black. Right, although this is linear, but it's fine, I think. At least there's the option for it, so now we can at least see color difference. And if I do, yeah, I think this is okay. So yeah, 0. So now these are all roughly at 15 units, so that's all roughly the same. So they're dark bluish. However, we might not want to do this linearly. We might want to do this logarithmically. Log scale. I don't think we want to do a log. No, because log goes like this, right? We want to do a I think we want to do an inverse scale. Yeah, we want to do I think an inverse square root. I think we want to do the square root of the distance. Okay, let's try that. So I think that way it's basically 1 divided by the square root, what would be the inverse square root, which should give us a bit more, yeah, that should give us a bit better scaling. So I think if we put this farther away to say application to like 20, minus 20, this shouldn't be completely dark. This should be still kind of blue. Because the drop off is much less. Yeah, there we go. We can clearly see the light difference. This is dark blue, but, sorry, this is quite light blue, but this is much darker. And if we move this to say minus 100, we should see that this is getting more and more dark. Yeah, so this is much darker than that. Okay, I think that's exactly what we wanted. Okay, However, let me just put it back like this. So now we at least have a better support for different options. Oh, okay. Oh, wait a second. So I think the options is not defaulted to anything. Options. Yeah, sorry. This should be default to 0. Well, there's no options. But I think it's random initialized, so it could technically be indeed some weird value, right? But normal view, that works. Awesome, awesome. Okay. No, I think this works exactly as it should. Okay, this is cool. So it is actually quite late here. It's actually okay. It's actually really late. It's like 1:15 here, or 1:18, I should say. So I think I'm gonna call it here for tonight, and I want to thank you all very much for watching. If you want to see me stream next time, do leave a follow, and I will probably be streaming again on Wednesday, and this will probably be around 5 or 6 GMT +1 my time. So that would be roughly that would be late morning American time. Yeah, so that would be like 10-ish, no, 10 to 12 a.m. depending on where you are in America. So I think the West Coast would be -7. So if I stream at 5, that would be 9. Quick maths. And if it's the East Coast, it would be 11, I think. So yeah, definitely do follow if you want to see me stream again, or just hop in next Wednesday. I might be streaming programming, but I might also stream some game-related content. Depends really what I'm interested in at the moment. But anyway, thank you all very much for joining today's stream, and I think we managed to do quite some cool things today. Have a good